Hello friends, welcome to my channel. Let's have a look at problem 2327 together. Number of people aware of a secret. For this problem, we're going to share a dynamic programming solution in this video. First, I'll read through the statement and then analyze the problem and the method, and finally we share the code. First, let's look at the statement. On day 1, one person discovers a secret. We are given an integer called delay, which means that each person will share the secret with a new person every day starting from delayed days after discovering the secret. We are also given an integer called forget, which means that each person will forget the secret days after discovering it. A person cannot share the secret on the same day they forget it or on any days afterwards. So, given the integer m, return the number of people who know the secret at the end of day m. Since the answer may be very large, we return the result in the sense of modulo this number. So in example 1, so n equals 6, and delay equals 2, and forget equals 4. So on day 6, there are 5 people who know the secret. So we shall analyze this in more detail after we explained our method. So you can see the explanation to gain a feeling. So in example 2, n equals 4, delay equals 1, and forget equals 3. So the output is 6. Let's look at also the constraints for this problem. So n is greater or equal than 2, and less or equal than 1000. The second one is actually important. So the delay is greater or equal than 1. In other words, at least after 1 day, we can share the secret if we know it. And also it's less than forget, so that's the logical assumption, and less or equal than m. So with that said, let's look at the method. So here the method we're going to use is the dynamic programming method. We're going to use a 1D dynamic programming. So the procedure is as follows. So here we use DPI to represent the number of people who discovered the secret at day I. So they began to know the secret on day I. Then we can do the following reasoning. So at the current day, let's say day I, then dpi minus delay means that this is the number of people who know the secret at day I minus delay. So at current day I, this number of people began to share the secret to new people, to exactly the same amount of new people. So that's the first item. The second item is that dpi minus forget. It means this is the number of people who discovers the secret at day I minus forget. Then at the current day I, this number of people began to forget the secret, right? So as they know the secret forget days ago. So with that said, actually we can update the DP table, and finally we want to return those people who haven't forgotten the secret, right, at the n. So here it's a walkthrough for example 1. So here I marked the days the people know the secret. For example, in day 1, so the person A began to know the secret. It's his first day or her first day. So in day 1, there's 1 people know the secret. On day 2, so still only A knows the secret, because day 2 is still before delayed days, right? So we have A, but it's A's second day to know the secret. So we have 1 person know the secret. On day 3, this is the third day for A to know the secret, but it's after 2 days delay. So he began or she began to share the secret to another person B, and this is the B's first day to know the secret. Then on day 4, so this is A's fourth day to know the secret, and B's second day to know the secret. And B still cannot share secret to new person, but A can share the secret to another person. That's called C. So it's the first day for C to know the secret. And then let's look at day 5. So this is the 5th day of A. So in other words, after forget days. So A forgets the secret. Let's remove A here. And this is B's 3rd day and C's 2nd day. So B can share the secret to a new person, D. It's D's first day. And C cannot share because he needs to wait for one more day. So similarly, we can see day 5 and day 6. Let's look at day 6. So in day 6, so this is B's 4th day, right? And this is the 3rd day for C and the 2nd day for D. So both B and C can share the secret with a new person. Let's call it E and F. So this day is also the first day of E and F. So if n equals 6, we should return 5 because the 5th person knows the secret. Let's look at one more day on day 7. So on day 7, this is B's 5th day. So he forgets the secret. So we remove B. So it's the 4th day for C, right? And it's 3rd day for D and 2nd day and for E and F. So both E and F cannot share the secret to new person, but both C and D can share the secret with new person. So we call them G and H. So this is the first day for GH to know the secret. So if we have n equals 7, so this is the number of people who know the secret. That is 6. So with that said, so I think we're ready to write the code. First, I'm going to initialize a DP table. So here I'm initialize using this one, 0 times n plus 1. So we'll set dp1 is 1 because of the assumption at day 1. So one person discovers the secret. So with that said, I think also we want to initialize another variable in shares. So it means how many people at current day can share secret. So initially we should set this one to be 0 due to the assumption that delay is greater or equal than 1, right? Because we need wait at least 1 day so that we can share a secret. So with that said, let's do the scan. So for I in range, so we have set the value for day 1. So we start from day 2 and then ending at day n, right? So we write n plus 1 here. So we're going to update this n shares. So this n shares actually equals the previous state of it. So we have this number of people began to share the secret. So we add this dp I minus delay. But there's a technical part. Is initially I may be less than delay, right? So meaning that no people began to share the secret. So here we are going to treat it like this. We'll use max I minus delay. So if I is less or equal than delay, so actually this expression will give us 0. So dp0 is 0 by default. That's incorporated this special case. So similarly for the decrement, because this will be dpi minus forget number of people to forget the secret. So we're going to minus dp this I minus forget, but still I can be less than forget. So we're going to use maximum of I minus forget 0, taking advantage of the initialization in dp, that is dp0 equals 0. So with that side, I guess once we update the variable in shares, we're going to set this dpi equals this new state of shares, and number of people can share secret. So with that said, then we're going to return the result. What we want to return is that at the end of day n, the people who haven't forgotten the secret, that is those from forget forward, right? So these people haven't known the secret more than forget days, so they haven't forgotten the secret. So we're going to return the sum of this thing. But don't forget that we need to do this modulo a big number, 10 to the power 9 plus 7. And so actually we can also modulo this big number in the update for in shares or set the DPI, but it will be okay. We do it here. So let's do a check for the special case. So it passes the first example. Now let's do a generic case check. Yeah, it passes the generic case. Yeah, I guess for this problem, that's about it. I guess if you have some confusion, it's good to walk another example through, marking what's the day for these people to know the secret, like here 1, 2, 3, and 4. So this way you can track the number of people who know the secret specifically at each day. So with that said, I guess that's about it for this video. Thank you very much.